Okay, so today what we're going to talk about are z-scores. So let's review. Consider the following data distributions. For each of the following distributions, indicate if it's a normal, approximately normal, skewed, or neither. All right, and then, of course, then you have to, I want you to tell me the reason why. All right, so let's take a look at number one. So number one is normal symmetric. Okay, this is a normal curve. Okay, and the reason why is because it's symmetric. Okay, and notice it looks like a mound. It's mounded shape. All right, let's take a look at B. B is also normal. Okay, it's symmetric. This is also has a mound shape. Okay, notice that C goes like this. Looks like it has a tail, so that's skewed to the right. D would be normal, symmetric. Okay, it's a mound shape. Okay, so now take a look at E. E is symmetric, but it doesn't have that mound shape, doesn't look like this. So this is actually neither, even though it's symmetric. So it's neither even though it is symmetric, because it does not have a mound shape. Mound shape. Okay, so let's take a look at what it says down here. It says a normal distribution is a distribution that has, actually let me move this all up. Okay, so a normal distribution is a distribution that has a particular symmetric mound shape as shown below. So see this shape here? It looks like a mound. It's called a bell curve or the normal distribution curve. Okay? Many populations have a distribution that can be well described with what is known as the normal distribution or the bell curve. So something that you always hear them using the bell curve is when someone has a baby, and if you hear someone say, oh, what percentile is your baby's weight in, that when they talk about, oh, my baby's weight or my baby's height is in the 95th percentile, they're talking about this bell curve. Okay, all right, so let's talk about a z-score. Is used when calculating probabilities, measures the number of standard deviations away from the mean, represents a variable that has a standard normal distribution, so we're talking about this curve here, where the mean is at 0, which means it's right in the middle, and is 1 standard deviation, so going to the right 1 and to the left 1 standard deviation. Okay, so let's look at the other side. Okay, so a positive z-score corresponds to a value that is above the mean, and a negative z-score corresponds to what is below the mean. So when you have this mound, right, we have here's the middle is the mean, right, which is your 0. So 1 standard deviation or a positive z-score would be above. This would be above at 1, and this would be below at negative 1. A z-score is calculated by the value minus the mean over the standard deviation. So you have to know this. So remember I said the other day, make index cards. So put this on an index card so you know how to calculate a z-score. All right, so let's take a look at the examples down here. All right, the prices of the printers in a store have a mean, so I'm going to just put this as X bar, of 240, which remember is also your mu, and a standard deviation of $50. The printer that you eventually choose costs, so the value of your printer is $340. What is the z-score for this printer? So your z-score is the value of your printer, which is 340, minus the mean, 240, divided by the standard deviation, which is 50. So that's 100 over 50. So your z-score is 2. Okay, which means it is 2 standard deviations above the mean, because it's positive 2. So it's above the mean. All right, let's take a look at 2. Just going to move everything up a little bit. Okay, so it says, how many standard deviations above the mean was the price of your printer? I just told you. So we have the mean, right, is 240. You paid 340, okay? The standard deviation is 50, right? So from 240 to 340 is $100. So you have 2 standard deviations, right? 50 plus 50 is 100. So you are 2 standard deviations above the mean. That is your z-score, 2 standard deviations. So you paid 2 standard deviations above the mean. Okay, so if you look at the bell curve, right? So in the middle was our mean, right, which was 240. So here's 1 standard deviation above the mean, right? 1 standard deviation would be $50. That would put us at $290. So now we are at 2 standard deviations above the mean. So we're over here at $340. Right, so from here to here was $50 and then another $50, 2 standard deviations above the mean. All right, and let's look at the last one. It says, what percent of the printers are between $200 and $300? Okay, so what you're going to do is you're going to find your z-score for each one. So find the z-score. At $200. Okay, so that's going to be 200 minus 240 divided by 50, right? It's the value minus the mean divided by 50. The standard deviation is negative 0.8. So now you're going to find the z-score at 300. So that's 300 minus 240 divided by 50. So it's 60 divided by 50 is 1.2. So now what you're going to use here, you're going to use your calc. So make sure you have your calculator. If you don't have your calculator, put me on pause right now and get your calculator. All right, so what you're going to press on your calculator is this. You're going to press the distribution key. So find the distribution key. Okay, so over towards the middle, towards the top, middle top. All right, and then you want number 2, which says normal CDF. Okay, and then it gives you parentheses, and then you're going to put in your smallest number first, your lowest number, which is negative 0.8, and then your upper number, which is 1.2. Your mu and your standard deviation, you could just bypass that because that's 0 and 1. Okay, and then you hit enter, and you get 0.673. So you change that to a percent, which is approximately 67.3%. Okay, and then tomorrow in class, I'll show you how to use just these 2 numbers to check to make sure this is correct. All right, and that's it, and we'll practice some more in class tomorrow. Have a good night.